Hi, this is OK1VWK, and this is a presentation of my VHF setup for 2 meters band, which is prepared for VHF field day. So, as you see, I am using HF radio Kenwood TS590SG as a base HF radio, which is used together with transverter to from 28 megahertz to 144 megahertz. I'm using Hotel Alpha 1 Yankee Alpha transverter production. This is transverter, and this is from the same company. I have crystal filter, which is filtering for TX and RX my IF frequency, my selectable crystal filters, which are improving the selectivity of the radio. So for the controlling and audio input-output audio processing, I'm using the last version of Microham, the version 3, and this setup is working on the air without no problem. But big issue which I was solving now was CAT communication. You can see that Kenwood uses two possibilities for the communication. First is over the serial port, and it means RS232, let's say COM. And second one is, it was -67 for the communication rate settings, and -68 is the same parameter for USB virtual serial communication over the USB interface on the radio. So I decided for back compatibility to use standard serial port on the COM. I will show you on the back plane. This is the serial port, this is the USB. USB is not used. The differences between serial and USB are that over the serial communication is possible only control the radio. Over the USB you are able to handle not only control for the radio, but also audio input-outputs from the internal audio equipment. But internal audio equipment in this radio is only 16-bit. So Microham contains 24-bit sound engine, 24-bit audio, which has bigger dynamic range, audio dynamic range, and a better performance, not only for digital modes. So that's a short presentation, and I'm long-time user of TS590SG+HA1YA 1000 and also ICOMs and so on. And big advantage for me, it was both platforms, TS5 and ICOM, have a little bit robust and simple CAT protocol communication, which is not sensitive to CAT settings on the logger. You can see that Kenwood has to be proper set for the CAT communication, because His communication protocol on the CAT is more complicated and more sensitive for overload, and it can cause no communication with CAT or erratic communication between the logger, microham, and the radio. So I decided to solve it by the own research, because standard manuals are a little bit not so detailed in this parameter. So as you see, I decided to change the pooling rate for the CAT interface for the information from the radio, from the auto to the fixed pooling rate in milliseconds, because it is the key factor of stability CAT communication on the Kenwood radios, like my TS590SG. So after this, I have fully stable communication between the logger, microham, and radio. Before, when there was set auto, it was tending to be not stable or absolutely without communication over the CAT. You can see. I will change the window. This is the microham router. I will show you the current communication. You can see the log. This is standard pooling rate with fixed 700 milliseconds questions and answers between the logger, microham, and the radio. When you have auto settings on the logger, here you can see the auto is good enough for ASU without no problems. But for the Kenwood, you have to change for this value. For example, the good enough are values starting from 50. From now 500 to the maximum, which is 1 second pooling rate. The 700 milliseconds is mid value between the starting and stop range, and it is good enough for stable working of the CAT. So it seems currently it is okay, and I will show you how it is working with transverter, because I have a 28 MHz 10 meters radio with transverter, and you can see it shows final frequency on 2 meters band without no problem in the logger. I am changing VFO manually by my right hand currently, and this is the pooling rate 700 milliseconds response of the frequency on the display. This setting is accessible by the configure interfaces in the WinTest, and this is 700 pooling rate, but sorry, my mistake. frequency offsets. Frequency offsets is the menu, which I mean by default is frequency offset enabled, but it is set to the 0. It means that there is no difference between the frequency from the radio, from the CAT, and frequency showed by logger, by WinTest. When you set offset frequency, which is a difference between your IF transceiver and your final frequency used for communication, logger shows the final frequency. We can demonstrate it by disabling this functionality now. I will disable, and you can see that currently it is showing the real frequency of the IF radio, which means Kenwood TS590, because it is only HF radio. And I will set it back to the enable. As you see, you can define different offsets for each band and each radio. The standard is radio 1 or radio 2. Then each radio can be set independently by the current band, and there is no problem. Use more setup for each band and define different offsets. So that's all. Thank you for watching, and nice to see you.